Hey everyone, in anesthetics there's this concept that comes up called the concentration effect. And what the concentration effect is it's usually described in association with nitrous oxide. And the reason why it's described with nitrous oxide is because nitrous oxide has a very low blood gas partition coefficient at 0.47. But what's interesting about nitrous oxide is that it has a very high MAC. So MAC is the minimum alveolar concentration. And when it's a very high MAC, it usually means that it's not very potent. So the MAC for nitrous oxide is around 105. And what this means is that you need to deliver very high concentrations of nitrous oxide for it to get into the bloodstream and cause an effect. Well, to cause an effect, because it actually easily gets into the bloodstream. So when you look at the gases within the alveoli, you've got CO2 and you've got oxygen. And oxygen is normally diffusing into the blood vessels, while CO2 is normally diffusing out. But you also have nitrogen. And nitrogen has a blood gas coefficient of 0.014, while nitrous oxide has a blood gas partition coefficient of 0.47. So what this means is that nitrogen diffuses slowly, and it diffuses the other direction as well. But then, when you deliver high dose nitrous oxide, because remember nitrous oxide has a very high MAC, so it's not very potent, so you need to deliver high doses, and normally it's about 60-70%. The nitrous oxide goes into the cell and it rapidly diffuses into the blood vessels, while nitrogen slowly diffuses out. And the overall effect of this is that you have a loss of gas volume. As more gas, the nitrous oxide, is diffusing out, the nitrogen that's diffusing into the alveoli. So the overall effect of this is that because the volume's decreasing, the alveolar volume shrinks. And as alveolar volume shrinks, our other gases, our oxygen, our CO2, become more concentrated. And this is a really important concept because then what it goes on to describe is something called the second gas effect. And what the second gas effect is that people notice that when you deliver your nitrous oxide with another anesthetic, such as sevoflurane, you deliver the nitrous oxide into the alveoli with some sevo as well. And then because the nitrous oxide rapidly diffuses into the blood vessels, it very quickly shrinks the alveolar size, so the volume decreases. And because the volume decreases, the concentration of sevoflurane goes up rapidly. So this then, because there's an increased partial pressure of sevoflurane, makes the sevoflurane diffuse more rapidly into the blood vessels because the gradient between the two is low here, but much higher here.